In this video, I'd like to go over an acronym that you can use to help you with basic metric conversions, especially the ones that we'll be seeing in clinical math. I will also go over a few of the ratios related to the metric system, and also called conversion factors, that you're absolutely going to need to memorize. So let's first look and recall this chart, and you saw this in the last video. This is on your content guide, and this gives you an idea of how the metric system is constructed. We know the basic unit is 10 to the 0, or the single units, and as we accumulate these units in groups of 10, 100, or 1,000, we see we can just add the prefix kilo or hecto or deca to that basic unit, whether it be gram or liter or meter or whatever the case may be, and that will represent, in this case, 1,000 if we're talking about kilogram or kilometer or kiloliter. Same thing here when we talk about parts of that basic unit. And we saw in the previous video that depending on where we're starting and where we're ending up, we can just use the number of spaces from the first prefix to the basic unit or the other prefix, and that tells us the direction that the decimal point will be moving in the conversion. Now there is a nice acronym here that we can use, or a nice kind of mnemonic. I don't know if that's the right phrase, but it's a nice phrase that we can use to remember the prefixes for kilo, hecto, and so forth. And that's King Henry died by drinking chocolate milk full of microorganisms. And you can see that the K, H, D, B, D, C, M, and M, especially micro, align with what we see in the chart. So let's actually use this to convert 500 milligrams to an equivalent amount of grams. So what I would do first is write the letters, in this case the letters that represent the prefixes for the metric system that I'll be using. And I'm going to use the King Henry died. So King Henry died by drinking chocolate milk full of microorganisms. And that full of in the phrase are just spaces. It allows us to space between the milli and the micro. So now we have 500 milligrams. So I'm starting at in this case, the milk, because that represents milli. And I'm going to the basic unit of grams. So I see the number of spaces here, 1, 2, 3. We have 3 spaces, and the basic unit is 3 spaces to the left. That is telling you how the decimal point will be moving to find its equivalent amount. So I'll be moving at 1, 2, 3. So I have 0.5, in this case, grams. Now, a good question is, does this make sense? Which one's larger? Is the milligram or the gram larger? We know that the gram is larger. So it makes sense that it takes a lot of milligrams. It takes 500 of them to equal a half of a gram. That makes sense. Always stop to think, does your answer make sense? Go ahead and try the next one if you want to pause the video. Before I get started, I'm going to think, should my value, if I'm going from milligrams to micrograms, should my value be larger or smaller when I'm done with my conversion? Micrograms are a lot smaller than milligrams. So I know when I'm done, I should have a larger number here because it takes a lot of micrograms to make up 9 milligrams. So I'm going to do the King Henry died by drinking chocolate milk full of microorganisms. See, we're starting with milli, going to micro, so that's 1, 2, 3. We're moving 3 spaces to the right. That's describing how the decimal point's going to move. So I'm starting with 9, or 9.0. 1, 2, 3. We have 9,000. And that makes sense. There's a lot of micrograms in 1 milligram. Now I'm going to go ahead and finish these last 2. If you want to pause the video and try them, please do. So I went ahead and used my phrase, the King Henry phrase. I'm converting milliliters to liters in this first example. So M is where the milk is, and I'm going from the milk to the by, or the basic unit, because I just want the basic liter. So my decimal is moving 3 spaces to the left. I move that and get 0.347 liters. Okay, and finally, kilograms, that's the beginning for king, going to the basic unit, grams, that's 3 spaces to the right. That's the decimals moving 3 spaces to the right. I get 14,000. Now you might be looking at this and saying, well, 3 spaces to the right, 3 spaces to the left. A lot of these are dealing with 3. And that is because when we consider 10 to the third power, we're talking about 1,000. And these are common conversions in clinical math. So let's go to the next slide, and we're going to actually repeat. We're going to do these same conversions, but using ratios and proportions, using the ratios that you need to memorize as soon as possible. I'm now going to use ratios and proportions to convert the same examples that we saw on the last page. So down here at the bottom, I wrote down a few conversions that you absolutely need to know, and you'll be using them constantly in this course. The first is knowing that there are 1,000 grams in 1 kilogram. 1,000 grams in an equivalent number of kilograms is 1. We can also take this and write it as a ratio. So 1,000 grams to 1 gram, or 1 kilogram over 1,000 grams. And when you simplify this, you're going to get a unit ratio, either as grams per kilogram or kilogram per gram, depending on, obviously, the placement of the units. The next column goes from milligrams, milli, to the basic unit. So first milligrams to grams and milliliters to liters. This is the same, right? Milligram, milliliters, talking about milli, back to the basic unit. But these are the physical quantities that we'll be using, grams and liters. So 1,000 milligrams is 1 gram. 1,000 milliliter is 1 liter. You'll be seeing those constantly. And just as we saw over here, we can write this as a ratio, either of 1,000 over 1 or 1 over 1,000, depending on whatever the conversion is that we're doing. And we'll see that actually next week when we do dimensional analysis. And finally, there are 1,000 micrograms in 1 milligram. And depending on how you want to utilize that relationship, we can either write it as micrograms, milligrams, or the inverse, milligrams to micrograms. So I want to do these examples. We'll do the first 2 together, and then I'll pause the video and finish the last 2. We need to convert milligrams to grams. So the first thing you need to do if you're using ratios and proportions is to think about the number of milligrams to grams. What is the ratio or conversion factor, the number of milligrams to the number of grams? And as we should know, and we will need to memorize, I know there are 1,000 milligrams in 1 gram. These are equivalent. So I'll start by writing that down. And I'm going to write that actually as a ratio. This 1,000 to 1 needs to stay consistent. This is that invariant relationship between these quantities. So I need to find an equivalent number, equivalent ratio, grams on the denominator and milligrams on the numerator, and I'm converting this is actually 500 milligrams, and I need to figure out how many grams that is. So I have a ratio. I know there are 1,000 milligrams to 1 gram. That ratio must be the same for every conversion between milligrams and grams, and I'm looking for an equivalent ratio, but I'm talking about 500 milligrams. And now I'll solve this very much like I did in the previous module. So I'm going to look at this and say, well, the milligrams here are just being divided by 2. I have 1,000 milligrams. To get to 500, that's just dividing by 2 or multiplying by 1/2. So that same factor is going to happen to the number of grams. So I'll have 1 divided by 2, or 0.5 grams. You could also cross multiply here, or you could look at the invariant relationship between these quantities. Any of these will still result in 0.5. The next example, we are going from milligrams to micrograms. I know that there are 1,000 micrograms in 1 gram, or excuse me, 1 milligram. That's what I know, so I'm going to write that as a ratio. That is the ratio that needs to hold. Every pair needs to be equivalent to 1,000 over 1. And I'm looking for 9. Whoops, excuse me, that's not correct, because we know 9 is going to be here in the milligrams. I don't know how many micrograms that is. So I made a quick mistake there. 1,000 micrograms to 1 milligram. I'll start with what I know. I'm looking for micrograms, so milligrams is 9. And now I'm going to use, in this case I see milligrams. That's increasing by a factor 9. So will the micrograms. So we have 1,000 times 9, that's 9,000 micrograms. So if you want to go ahead and pause this video and finish the next two, start by writing the ratio that you know, and then think about what you're looking for and what you still is unknown, and use what you learned about ratios and proportions to find that unknown missing value. So I went ahead and converted these last two examples. I started by, in the third example, going from milliliters to liters. I know there are 1,000 milliliters. It's equivalent to 1 liter. I wrote that as a ratio. I then considered an equivalent ratio of milliliters to liters when I'm talking about 347 milliliters. And I used cross multiplication just to show that you can use any of the methods that we learned in the previous module. So I cross multiplied. 1,000x equal 1 times 347 divided by 1,000. I got x equal to 0.347. But then I also remembered that's not your solution. Your solution then therefore is 0.347 liters. So we want to go and add that unit. And then the final example, kilograms to grams. I know 1 kilogram is equivalent to 1,000 grams. I started by writing the ratio, and just to show you that you can write the ratio in a different way, I started with 1 over 1,000, 1 kilogram over 1,000. The previous ones we had 1,000 in the numerator. It doesn't matter because on the right-hand side of this equation, we're still going to have the units line up. So we have kilograms and kilograms, and I know that there are 14 kilograms. I just am looking for the equivalent number of grams, and I used the covariant property here, knowing that the kilograms is increasing by a factor of 14. Same thing must happen with the denominator, so 1,000 times 14, 14,000 grams. Now, I would encourage you, even before you make the conversion, to think about whether or not your answer will be larger or smaller than what you're starting with. And that's going to take some practice, just knowing that 1 kilogram is larger than 1 gram, and 1 liter is larger than 1 milliliter. So it takes a lot of milliliters to make up 1 liter. It takes a lot of grams to find an equivalent number of kilograms. That's going to be an important and informal way to think about the problem in order to start with the correct ratio.